In the last 10 or 15 years, we've seen a very rapid increase in interest for on-farm storage.
For growers, storing grain on-farm presents some advantages.
There's a lot of opportunities for domestic sales for growers, and also we're finding that growers are able to do some quality tweaks to their grain before they actually sell it, and that can help in the value of the grain.
Maintaining grain quality presents challenges, but some of these can largely be solved with the correct aeration.
Aeration can have a number of positives. It cools the grain, which reduces the population growth of insect pests, and it can also help with grain quality issues.
Even with fumigation, that aeration has some benefits for pressure testing the silo and also for clearing the silo after the fumigation.
As well as cooling, aeration can be used to dry grain.
We're doing more and more high moisture harvesting these days, just to spread logistics at harvest and also to reduce our risk a little bit for downgrading of quality and yield through wet weather at harvest time. So to have the ability to stick it in the silos and again have the aeration controller automatically take care of getting that grain moisture down over time makes harvest a lot easier.
But the airflow required for drying is vastly different than for cooling.
Cooling requires around 2 to 3 litres per second per tonne, and if you want to get a drying operation done, you need over 15 litres per second per tonne.
From 2 to 15 is a hefty jump, and just because the fans on your silo are turned on, it doesn't mean you're achieving these rates.
And one of the things that often is quoted in the industry is this fan will give this many litres per second, and that's not the full story. And we need to understand that a fan has work to do and it's working against the back pressure.
Back pressure is the amount of pressure on the fan's output side, preventing it from delivering the full capacity of airflow it could deliver in the open air.
A silo full of grain has a different back pressure than an empty silo. So even though the fan may be delivering a certain volume of airflow when the silo is empty, when that grain silo is full of either grain or pulses or canola, the characteristics could be very different.
There are many variables that affect the amount of back pressure.
The amount of venting, so we're hoping that's not restricting the fan, the amount of grain in the silo, the type of grain in the silo, so if it's a small seed like canola, that fan's got more work to do than a larger standard grain like wheat. The ducting design.
With so many variables, how can you be sure you're delivering the airflow needed for cooling or drying? Well, thanks to a project backed by GRDC through the CRC for National Plant Biosecurity, an easy, low-cost solution may be in the pipeline.
This project's attempting to design something that's simple for a farmer to build out of readily available materials, that he can then have confidence that his equipment is obtaining the desired airflow rates.
The first stage involves testing the accuracy of wind speed meters positioned on the intake side of fans working against a range of back pressures.
We're trying to look at some simple equipment and a multiple number of different types of instruments, both right up to the engineering style of instruments, all the way down, if you like, to quite reliable wind anemometers.
Once growers are sure their equipment is obtaining the correct airflow, further benefits can be gained by using an automatic controller to ensure your fans are operating at the optimum times.
Aeration controllers just give a better end result and a better performance than what we might achieve through just manually turning fans on and off or even using the time clocks.
To have a system that's fully automated that you can just set and forget, that picks the right temperature air and moisture air, and then either keeps the grain cool or dries the grain over time is a big help.
An aeration controller is available right now, but what these guys are working on is something new. A simple, low-cost way to measure the output of fans in your aeration system will be a welcome addition to the tools available to growers. Having a way to measure airflow means growers can take action if they're not obtaining the correct rates for cooling or drying.
You can very quickly then identify that there's a problem and then often it's not too much of an issue to actually solve that problem. It could be as simple as that you haven't provided enough venting, or it could be as simple as that fan was never designed to go on that size silo. So there's often some really nice outcomes that by a couple of simple measurements you'll find that a grower says, my goodness, I didn't realise that we weren't getting the proper performance, and we can achieve so much more out of our quality of storage by just tweaking one or two things.
And it should help growers make the most of their on-farm storage.
This project will allow every farmer to measure the working airflow rates on the equipment that they already have, and allow farmers to test the new equipment that they purchase to see whether it suits their needs.
This hopefully will be a very practical, usable outcome for growers to use and actually achieve better results on their farms in their grain storage facilities.